Shrishti Singh. My register number is UR14CS232. Today we are going to see the 7th exercise of our System Software and Compiler Lab. Our 7th exercise is based on predictive parser. Now in this particular program, our aim is to parse a given string using non-recursive predictive parsing for a given grammar. Now what happens now, whenever we do a recursive descent, like it is like a top-down parsing technique that construct a parse tree from the top and the input is read from left to right. It uses procedures for every terminal and non-terminal entity. This parsing technique recursively parses the input to make a parse tree which may or may not require backtracking, but the grammar associated with it, if not factored, cannot avoid backtracking. A form of recursive descent parsing does not require any backtracking is known as predictive parsing. This parsing technique is regarded recursive as it uses context-free grammar which is recursive in nature. Now in this particular exercise, what we are doing is initially first we are importing all the packages: buffered reader, input stream reader, array list and scanner. My class is my array stack. Now we have one character array and we have a top and size. Now what will happen, we'll declare the size and the array. Top will initialize as -1 as it is a stack. Now if my top plus 1 is greater than the size, then it will definitely give the error message, it will throw an exception that array index out of bound because it should be -1. Now if it is less than size, then what will happen, my array will be initialized as plus top equal to I, and then we'll use pop out to pop the values out. To return array will be do top minus, then 1 values from the top will get popped out. Now what happens now in this particular thing, what basically we do is, after assigning this thing, we set the input to point to the first symbol of our word with a $. We'll always enter grammar which we'll enter, that is which we write with terminals, we'll always enter it with $. We'll repeat this method, and if x is at the top of the stack symbol and the symbol is getting pointed to that input, then x will be a terminal of 4. Then if my x value is equal to a, as you will see over here, these are all over here, we are just asking the user to enter the number of terminals, non-terminals, then non-terminals in the grammar, enter all the terminals, semicolon, all the terminals which we have entered, how many number of terminals we want. One by one all the terminals will get entered from the array list. Then we'll ask to enter all the non-terminal one by one, and instead of epsilon we are using @ symbol over here. As you can see, now we'll enter the row and entities of the transition table. Now we'll make a transition table and we'll enter all the row entities. Transition SR int 1 for int s equal to 0, s is greater than state, set s plus plus, system.out.print transition, then int y. Then what we'll do, we'll give the input to the parser and we'll enter input with $ and hash sign. Now we'll push the stack $. Now index equal to 0, system.out.println stack input output, while my input.char index is my hashtag. If my last value, if it reads it as a hashtag, then only it will display all the characters, input.char, all my strings, index value, character 2, index 2 values. Now if my transition index 2, index 1 is equal to null, then it will say that my string is not accepted. But if at all in println this value input.char index plus transition index 2 index 1 transition split, then if at all these symbols are coming, then what we'll do, and we'll see over here. Now if my x is a terminal, if my x is equal to small a, then we'll pop x out from the stack and we'll advance the input one step either. Else if it is not possible, then it will send us an error message, as you can see over here. Then if my x comma a, that is my m value, if x equal to y1, y2 over here, if my e is equal to gives ta, then what we'll do, we'll pop x from the stack, we'll push y and y1 onto the stack, and y1 will come on the top. The output of the production then which we'll get will be x will give y1, y2 till yn. We'll end this thing. If this is not happening, then else error, and then we'll perform. If there's no error, we'll perform the parsing till we get our x value equal to $. Only. Now when you run this program, you'll see, actually I already stored the values over here. Now if you run the values, you will see it is saying we need to enter the number of terminals. I have entered 6. Enter the number of non-terminal 5. Enter the starting non-terminal in the grammar E. Please enter all the terminals simultaneously. A plus star open bracket close bracket dollar. Please enter all the non-terminals simultaneously. E, A, T, B, F. For epsilon, we are using our @ symbol. Now enter the row entities of the transition table. E gives TA null null. E gives TA null null. We are entering it into our transition table. For my second row, it is null. A gives plus TA null null. A gives @. A gives @. For my third row, T gives FB null null. T gives FB null null. For my fourth, it is null. B gives @. B gives star FB null. B gives @. B gives @. Enter the row entities of the transition table. F gives A null null. F gives F R E null null. Now over here, as you can see this is the transition table that has been created. E gives TA. You can see number of rows 1 2 3 4 5 rows we entered. It is come in this format. Now we have to give input to the parser and we have to enter input with this symbol. Now A plus A star A dollar hash we are giving. So this is a valid input. Now what will happen in my stack, my starting of the stack as we initially described, it is E dollar A. E gives TA is my first. Now what will happen, this TA will go inside A, then T gives FB. Instead of A, this FB will come and it will and the parsing will be done in this way, and at last it will say parsing successfully completed. That means at the last I'm getting my input as dollar, only dollar is left and my stack top is S. So what does this particular implies, that my string has been accepted. This string, whatever which we are given over here, is getting accepted at the last. If it is not getting accepted, it will give an exception and it will give an error message that the string cannot be accepted. So this is basically my 7th exercise of my system software and compiler, in which you have to do with predictive parsing. Thank you.